Lesson 40, simplifying radical expressions. That's too bright. I'm just going to turn this off. There we go. So when you have the nth root of b, we have what is underneath the root sign is the radicand. It's called the radicand. The root sign is called the radical. Oh, I guess I should call it the radical sign. It's called the radical. And n is called the index. And if you do not see a number inside, then the index is, then n equals 2. So if there's no number there, then it's a square root, or n equals 2. When you have the nth root of two numbers multiplied, or the product of two numbers, it's just equal the nth root of the first number times the nth root of the second number. And you can go back and forth. So let's make that an if and only if statement. So if you have it written this way, you can combine it under 1, or if you have it written this way, you can separate it if you need to. This is for n is always greater than 1, and a and b are real numbers. If n is even, then the square root of x to the nth power is just equal to x to the half of that power, n divided by 2. So in other words, the square root of x squared is just x, the square root of x to the 4th is x squared, square root of x to the 6th is x cubed. So you just take half of that power. If n is odd, the square root of x to the n, so n is odd, we take half of 1 less. So we take half of the even number that's just below that odd number. So, and then we have 1 of the x's left inside the square root. So you have x to the n minus 1 divided by 2, and then times that by the square root of x. So for instance, if you had x to the 7th, you would take half of x to the 6th. So on the outside you have x cubed, and then you'd have a square root of x left over. And I'm going to show you some examples of this too. So for example, the square root of x to the 6th, 6th is even, so it just equals x to the 6th divided by 2, or x cubed. If you had the square root of x to the 7th, you're going to have the square root of x to the 6th times the square root of x. And that goes back to this if and only if statement. You could kind of break it up to the even number and then one more. And x, square root of x to the 6th, we just clarified was x cubed, and we still have the square root of x, which would be left over. And that's kind of what this means here. To the 6 over 2. So here's an example of some of the things we're talking about. So we have the square root of 3 times the square root of 6. Now we can put that together to the square root of 3 times 6, but I like to write 6 as the product of 3 and 2. I look for doubles, so you find the square root of 3 times 3 is just 3 times the square root of 2. So the answer of square root of 3 times square root of 6 is just 3 root 2. The cubed root of 750. If we write 750 as prime factors, we look for groups of 3. So when we do square root, we look for groups of 2, cubed root, we look for groups of 3. So 750 is the same thing as 5 times 5 times 5 times 3 times 2. So we have a group of 3 here, which means we can pull out the 5 and then we have root 6 left over. The square root of 50m to the 9th power. You can write out the prime factors. So you have 2 times 5 times 5, and then m to the 9th is just m to the 8th times the square root of m, if you remember that. Oh, I guess I should have left it. I didn't have to put a square root there. I'll just put it under.
Wait, how do you take all three of those five out?
Because it's the cubed root, then the cubed root of 125 is 5. Because that's the number times 3 that will give me 125. And 125 times 6 is 750. So to take this, I look for doubles. I'm going to use the 2 5s. I'm going to take half of m to the 8th. So I have 5m to the 4th. And then what's left inside is a 2 times m. And that's that one simplified. Now another thing about roots is if you have the mth root of x to the nth, you can change that into a fractional exponent, and you take x to the n divided by m. So you take the exponent on the inside divided by the index. So I'm going to do an example like x to the 2.5. I better write example. So I'm going to write that as an improper fraction. I'm going to write 2.5 as an improper fraction. So it's x to the 5 halves. Remember that the m is the index. So the 2 is my index. So I have the square root of x to the 5th, which is the same thing as square root of x to the 4th times x, or x squared root x. Here's another example. The square root of 2x squared plus 12x plus 18. Now, because we have all those plus signs, we can't take any square roots until we factor it. So I'm going to take out a 2. So in my square root, I'm going to take out a 2, and I have x squared plus 6x plus 9, which is a perfect square trinomial. So I have the square root of 2 times x plus 3 quantity squared. Because this is a perfect square inside a square root symbol, x plus 3 will come out, and square root of 2 will be left over. So in my parentheses, I have x plus 3. Outside the parentheses, I have root 2. Be very careful when you see plus and minus signs inside a square root. You can't take any square roots until you have factors. We can't have any square roots or imaginary numbers or anything like that in the denominator of a fraction. So we have to do what's called rationalizing the denominator. That just means get a rational number in the denominator. So I'm going to explain this kind of using an example. If you have the square root of 5n divided by the square root of 2mn, because they're both under the square root sign, you can reduce the fraction. So I can actually take off an n off of both of them. That gives me the square root of 5 over the square root of 2m. To get rid of the square root sign, I multiply by the square root of 2m divided by the square root of 2m. This is really just multiplying by 1. So you're going to have the same value for your fraction. You just won't have a square root in the denominator anymore. So the denominator becomes 2m. The numerator becomes a square root of 10m. And you can't really simplify it because you'd have a 2, a 5, and an m. So that's your final answer. When you have a binomial in the denominator with a square root sign in it, you want to multiply by the conjugate of the denominator. So the conjugate is just the same numbers, just with a different sign in the middle. So if there's a plus sign here, you're going to multiply by this with a minus sign. If it's a minus sign, you'll multiply with the plus. So in this example, we have 3 plus root 2, and then we're going to multiply that by 3 minus root 2 divided by 3 minus root 2. This is now the difference of 2 squares. So you have the first one squared minus the second one squared. So in the numerator we have 3 minus root 2, and the denominator we have 9 minus square root of 2 squared is just 2. So we have as our answer 3 minus square root of 2 divided by 7. And then just remember you can't cancel anything because of the minus sign. Just in case this 7 were something that we're tempting to cancel, just don't. So I'm going to give you another example. I have to turn the page though. Are we all caught up? Okay. Another example. 7a divided by the cubed root of 4ab to the 5th. Because it's a cubed root, I have to have 3 of them multiplied together. So I'm going to multiply by 2 fractions that equal 1. And I'm going to do the cubed root of 4ab to the 5th divided by the cubed root of 4ab to the 5th, and then times it again by the cubed root 4ab to the 5th times the cubed root of 4ab to the 5th. So when I have the cubed root multiplied by itself 3 times, I just get what is inside. I get the radicand, which is 4ab to the 5th. In the numerator, I have the 7a and then the cubed root of these multiplied together. So instead of multiplying 4 times 4 and getting 16, I'm going to multiply using prime factorization. So this is 2 to the 4th power. Then I have a squared. I have b to the 10th. So I want the number that's divisible by 3. So I'm going to do times b to the 9th times b. That's going to give me. That way it's going to be easier to take the cubed root. So just right away I'm going to cancel these a so I don't have those in my way. So I have my new numerator is 7. I'm taking the cubed root of 2 to the 4th, so I can take one of the 2's out and leave a 2 on the inside. The a squared has to stay. B to the 9th is b cubed. I can take out a b cubed and leave a b on the inside. The hard part is remembering to put your index in when you're doing problems like these on your homework. So you got to remember to put, if it's a cubed root, put the cubed root. 3 of these b's can cancel. So I got b squared down here. 2 goes into 4 twice. So my final answer is 7 cubed root of 2a squared b over 2b squared. And that's the end of the lesson.